Welcome to Session 6, Circle Area. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to distinguish radius from diameter and convert between them. Use the order square, multiply by pi, then label square units. Estimate circle area before calculating to catch radius and diameter errors. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The circumference and area use the same radius differently. The square units describe the surface covered by circle area. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here is the central reasoning. A circular garden with diameter 12 et has radius 6 et, so its area is 3.146 squared equals 113.04 et squared. Using 12 squared would make the result 4 times too large. Squaring the radius is not an arbitrary rule. Circle area scales with the square every linear change. Doubling the radius produces 4 times the area, not twice the area. Estimates with a nearby rectangle or familiar benchmark. The estimate does not replace the exact calculation. It tells you whether the exact result belongs in the right neighborhood. Now add a precision check. For every area or boundary problem, identify exactly which segments form the base, height, radius, diameter, or outside edge. Convert units before combining measurements, keep full precision during the calculation, and round only once at the end if the context requests a decimal result. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, find the center to edge radius. Divide a given diameter by 2. Second, square the radius before multiplying by p. Third, use the value of p specified by the problem and round only at the end. Finally, check reasonableness. The circle's area must be less than the area of its surrounding. 2r by 2r square. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A circle has radius 6. Using p equals 3.14, what is its area? Step 1 is to organize the information. Find the center to edge radius. Divide it given d by 2. Step 2 chooses and sets up the relationship. Square the radius before multiplying by p. Step 3 carries out the mathematics. Area of a circle is pi times radius squared. 3.14 times 6 squared equals 113.04. A useful check is to area squares the radius. Circumference does not. The answer is 113.04. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. A circle has radius 9. Using p equals 3.14, what is its area? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 254.34. Area of a circle is pi times radius squared. 3.14 times 9 squared equals 254.34. A useful check is to area squares the radius, circumference does not. Use this coaching check as well. Write diameter to radius beside the diagram before substituting any circle measurement. Session recap. First, find the center to edge radius. Divide a given diameter by 2. Next, square the radius before multiplying by p. Then use the value of p specified by the problem and round only at the end. Finally, check reasonableness. The circle's area must be less than the area of its surrounding, 2r by 2r square. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.